In this video lecture, we'll cover topics from Module 1, Chapter 1. The topic is Introduction Part 1. The learning objectives. After watching this video lecture, you will be able to list out the characteristics of forces and identify types of forces as well as system of forces. It is from the first chapter of our GTU syllabus of Mechanics of Solid 213-0003. First topic is characteristics of force. As we know that force is a vector quantity. So what does it require? It required magnitude and direction to fully describe it. But consider this block, the force of 10 Newton is being applied in this direction. So that force can be applied at this corner or that corner or at any other point on this surface. So to make it more specific, we required point of application, that at which point the force is being acting. So basically force is having three characteristics: magnitude, direction and point of application. A concept of line of action, whenever the force is there, we considered an imaginary line. It is a line, imaginary line having infinite length. We consider it line of action. So it doesn't have any physical significance, but for ease of understanding in previous topics and for ease of calculation, we considered it as a line of action. The next topic is types of forces. The forces can be classified into many types. Few of the examples are given over here. The contact force and body force. What is contact force? The force is applied through direct touch or contact. At that time the force is called contact force. And if there is no physical contact in between two bodies, like this apple and the floor, there is no physical contact, still the force is being acting. It is a gravitational force. So it is called body force of the earth. And second is magnetic force. Again, in magnetic force there will not be any physical contact in between two bodies, still the force will be there. So it has been classified into contact forces, which does require contact, and second is body force. The next classification is point force and distributed force. Here a typical structure has been shown over here on which a man is standing with a single leg. So a force is being applied by the weight of that man on this body. It is an example of simply supported beam. So it is a point force. Force is acting at a single point. Whereas in this distributed force example, there is a long bridge and a train is traveling through that bridge. So the force by the train on the bridge is distributed throughout the length of the bridge. So it is called distributed force. A point force is at a single point described by an arrow, and distributed force is spread throughout the length of the body. Next classification is external force and internal force. So as we discussed in the last lecture, that external force is applied to the body and internal force is induced inside the body. So if we are applying a force over here and the body is constrained from here, this force is external force, but because of this external force, internal resistance to deformation will be generated. We call it stress. So stress is an example of internal force, and all the forces applied externally is called external force. Next classification is action and reaction. It comes from the third law of Newton, that wherever there is action, there will be a reaction. Let us take an example of a car which is moving in forward direction. So the force by engine will be there in forward direction. The gravitational force will be there in the downward direction. Frictional force will be there in the opposite direction of the motion. Apart from these three forces, a reaction force will be generated. It will be upwards. Why it is upward? Because it is in contact with the floor. The car is in contact with the floor, and because of this gravitational force, it creates a normal reaction upwards. Frictional force, it will be there in the opposite direction of motion. It is simply a resistance to motion. A body is sliding to any surface, any smooth surface or rough surface, a smaller or larger extent, a frictional force will be generated. Again, taking an example, a woman is pushing a block A push by her can be described in positive direction, the weight of the body in downward direction, normal force or reaction force that we say it is in upward direction, and fourth force, it is called frictional force. It will be there in the opposite direction of the motion. The next is wind force. It is generally considered in the structural design problems in the civil engineering, and it is an example of distributed force because it is acted upon a large number of surface. Next is hydrostatic force. A force is being applied by a fluid. It is called hydrostatic force. It is a cross-sectional area of dam. As per the calculation, maximum force will be there at the down direction, and as we are traveling upwards, the force is decreasing gradually, and that is why a design of dam will always be like this. It will have more cross-sectional area at the end, at the downwards, and the cross-sectional area decreasing as we are traveling upwards. This topic will be covered in the next semester. The subject is fluid mechanics. A thermal force. When there is a change in temperature, there will be a change in length. It is called linear expansion of the body. If temperature is increases, the length of the bar increases. It is because of thermal force induced inside the bar. We know from school times that the gap is always been left in between two rail of railway train. If it is not left such gap in the summer time, when these rails are heated, it will elongate, and if the gap is not there, such kind of distortion occurs. So to eliminate such distortion, initial gap is always been left in between two rails. The all concept is because of the thermal force induced inside the material. The next concept is system of forces. It is divided into coplanar force and non-coplanar force. Coplanar force can be further subdivided into collinear and concurrent force. So here is an example of coplanar and non-coplanar forces. In the first experiment, a force table will do the experiment of such kind of table where 4 strings are hanged at a single point. So because of these 4 loads, a tension is generated on all 4 strings, and all 6 tensions are an example of a force. So basically what we want to understand, all 4 tensions are there on the single plane. Line of action of all the forces are on a single plane, so it is called coplanar force. Whereas in the second example, all the forces are there in different planes, so it is an example of non-coplanar force. Next is concurrent force and non-concurrent force. Again, in the same example, line of action of all the forces are meeting at a single point, so it is called concurrent force. Whereas in this example, line of actions are not meeting at a single point. In fact, all the forces are parallel forces, so it is a non-concurrent type of force. Collinear force, when line of action of all the forces are same, it is called collinear force. In this example, all the forces are acting at a single line, so it is collinear force. A reflection quiz. Find one example of following types of forces from your day-to-day life and write down the example of each of the forces. Thank you.